Hi, Mr. Kane here, and we're continuing our look at the atom and the history of the atom and how it's put together. We're going to just recap a little bit. Niels Bohr, our Danish Danish friend, who was a student of Rutherford, Ernest Rutherford, the New Zealander, Manchester. He modified Rutherford's model of the how the atom looks like. The nucleus in the middle and the cloud of electrons around the outside of that. He modified that to say that the electrons are in orbits around the Sun, and so each orbit can fit only so many electrons into it. So let's have a closer look at how that operates. So here's his sort of model of the atom with the electrons orbiting around in distinct orbits around it, or energy shells around the nucleus. So here's the typical Rutherford sort of model: nucleus in the middle, electrons zooming on the outside. That's sort of the classic look of the atom, if you like. And Niels Bohr modified that to say that these electrons are in energy shells or layers around it, and we can put energy in and get an electron to move from one shell to the next. So we can get an electron to jump up to this layer here by putting energy in, but it will fall back down, and as it does, it releases a photon of light energy, and that's where we get different colors of lights by exciting different atoms of different elements. So his plan is what he came up with was that there's a nucleus in the middle, and there are distinct orbits or layers or energy shells around it, each one filled up with electrons, and they fill up from the inside layer to the outside layer. So this here is a calcium atom, and we can see it's got 20 protons, so therefore it's got 20 electrons, and they've filled up the layers. As you can see, there's 2 in that first layer, then there comes 8, and then there comes 8, and there's 2 have spilled over into the next layer out, the outside layer. So how does that work out? So we've got energy levels or shells around the nucleus of an atom. The first shell can fit 2 electrons, the second shell 8 electrons, the third shell 8 electrons, and at the level of science that we're working at here, that's pretty much all you need to remember. But as you learn about the periodic table, you'll be able to see how this connects to that table, and then be able to figure out for yourself what the next shells, how many electrons are in the next shells. So that's the outside shell, that's the really important one for chemistry, and it's called the valence shell. So how many electrons are in the outside shell determines sort of how this element behaves chemically. The valence, or the outside shell, is the important one. So there's 2 ways of talking about where the electrons are and describing the structure of an element. We can use what's called electron configuration, which is the shortest, easiest way of doing it, or the dot and cross diagrams, or as some people like to call them, the bullseyes, or the bow and arrow targets, if you like. And they'll take a bit more time, but we'll look at them both. So electronic configuration, where the electrons are. So we just put them down as numbers separated by commas. So for example, here's nitrogen. We can see from the numbers around it that it's got 7 as its number of protons, which means it has 7 electrons as well. So nitrogen configuration will be 2, 5. 2, 5. Why is that? We've got 2 in our first shell. That leaves 5 left over that spill over into the second shell. 2 plus 5 equals 7. 7 is the number of protons, therefore the number of electrons that it has. Okay, so that's where that 7 comes from, and that's how we get the 2 and the 5. 2 go into the first shell, it's filled up. What's left over spills over into the next shell. So let's try some out. So we've got calcium there, as we looked at that one before. Okay, it's got 20 protons, therefore it's got 20 neutrons. 2 fill up the first shell, 8 fill up the next shell, 8 the third shell, There's 2 left over still. They spill over into the 4th shell. Sodium has 11, so we've got 2, 8, 1, adds up to 11. Oxygen has 8, 2, 6. 2 and 6 add up to 8. 2 in the first shell, leftovers go into the next shell. Chlorine, 17 altogether, 2, 8, 7. Silicon is 14, 2, 8, 4 into the next shell. And the last one, boron, 2 and then 3. So 2 plus 3 equals 5. So you can see the numbers separated by commas describing how many electrons are in each layer around it. 2 in the first shell, 8 can fill the next shell, 8 can fill the third shell, and then anything that's left over you'll put into the 4th shell. That's all we need to remember at this stage of chemistry. Now the dot-cross diagrams, same sort of thing, but we're drawing like a bullseye if you like, and they're showing where they are. So we'll do our nitrogen one again, and we can do our nitrogen in there, and here we go. So we put the layers around it, N in the middle where the nucleus would be, and the layers represent where the electrons would go. So 2 go into that first shell, and then what's left over fills up the outside shell. Okay, so 2 plus 5 equals 7. Now we can draw the little crosses separately, although some people often like to draw them in pairs. It's up to you. I'm not sure exactly which is the preferred method, but either singly or in pairs. Just the important thing is to have the correct number in the correct shell. So let's try some out. So oxygen, we've got 8 to play with here. Chlorine's got 17. So here's oxygen, 2 in the first shell, and then what's left over, the 6 in the next shell out. Chlorine, it's got 17. We're going to need 3 layers around that. The symbols in the middle of the nucleus is 2 go into the first layer, 8 will fill up the next layer. What's left over is the 7, which then goes into the outside layer. Okay, sum up on that. Here's our classic look at the atom. Nucleus in the middle, electrons orbiting around the outside in distinct orbits, distinct layers. So the atomic number, how many protons is in the nucleus, and that tells us how many electrons there are. Atomic mass is the number of protons plus neutrons in the nucleus. Number of protons is, like I said, how many electrons we have. Electrons orbit the nucleus in shells or layers or energy layers. Each shell can carry only a certain number. So remember that 288 is all you need to remember at this stage of chemistry. And a happy atom has the same number of protons as it does electrons, so it's electrically neutral, and it has a full valence or outer shell. Now not all atoms can do that, and we'll learn a bit more about that later on, but for an atom to be happy, it's electrically neutral and with a full valence outer shell. So here's our periodic table, and this is what sort of happens with this. We're going to start looking at this in more detail soon. Each layer down the table is another energy shell of electrons. So we can see that in our first sort of layer here, the helium one, we've got 2 elements in that layer, and the next layer down we've got 8 altogether, and the next layer down we've got 8 altogether. So that tells you 288. The next layer down, how many is in there? We've got 18 in that layer, so that would tell you in the 4th shell can take up to 18, and then you can figure out the next layers down as you go. Don't forget though that this group here fits in the gap here somewhere. Okay, sorry, this one here, in this slot right here fits in, so that sort of shoves those rows apart a bit, and then you add this number into these 2 layers here. These 2 layers here have this slot added into them, so they tell you how many electrons in that layer if you want to figure that part out. Okay, so that's electron configuration, where electrons are around the the nucleus of an atom, and I hope that was helpful.